Hi guys, this is Miss Moore. Today we're going to talk about linear versus nonlinear functions. I'm going to ask you to pause this video and write down what you see, and then we'll talk about it in a second. Alright, so let's just look at the one side, linear functions. So we're just going to ignore this side and we're just going to talk about linear functions for the moment. The x and y values must both have exponents of 1. So we can't have x raised to the 5th or y raised to the 2nd. It has to be x to the 1st, which means there will be no number there. It'll just say x. And for y, it'll just say y. X and y cannot be multiplied together. So you cannot multiply x times y. That would be, a no-no. In order for it to be linear, the y and the x cannot be multiplied. X and y are not to appear in the denominator as an exponent or in the radicand. Now, this may help you to understand all that. Let's look at the other side, the nonlinear functions. So these are nonlinear functions. 2 plus 4 equals 6. There's no variable, so it's not a function. It's just a number. It's a constant. X squared plus 9. Oh, look. See that square? See that raised to the? It is not a 1, so therefore this is not linear. We happen to know that x squared is a parabola. Hopefully remember that. X times y equals 8. We're not allowed to multiply, so therefore this is nonlinear. 6 over x, the x is in the denominator. Again, we said that is not linear. 2 raised to the y power equals 8. Y being the exponent, that's not allowed. That is not linear. And here it is in the radicand. The square root of y equals 5. So we can't do that. That's not linear. Okay, so we're going to take a moment. We're just going to look at Desmo. I'm in Desmo, and if I type in y equals x, you can see that it creates a line. Let me go in and type y equals 2. Sorry, I somehow lost that. Y equals 2x. And then the next one we're going to do is y equals x raised to the 2nd power. Notice that that green line has created a curve. What is that curve? That is a parabola. Now I can turn that off and it may make a little more sense to you that you can see it. I can turn these off and all we see is the parabola. So x squared creates a parabola. In this case it's a happy parabola. Remember, if I transform it and make it a negative x squared, then I have an unhappy parabola. But at the moment, we're not going to look at that. We're just going to get rid of that. Let's look at y equals x raised to the 3rd power. Let me turn off the green. And you can see that that is not linear, right? If you look at these, let me turn them all off. Y equals x, that's a line, right? Straight line. Turn that off. Y equals 2x. That is also a line. It's a steeper line. If we compare these two lines, you can see that the first one versus the second one is much steeper because its slope right here, this 2, is moving it up twice as fast. Its rate of change is times 2. Now, if we look at this, we can see that that is a parabola. Anything that's x squared is going to be a parabola. And for x cubed, we get what I call a little swiggle. Okay? Okay, so now we're going to look at the absolute value, ABS of x. Notice that that is a v. It is linear on either side of the y-axis right here, but it is not a linear function. It goes down this way, and then it switches directions and goes this way. So as its whole, it is not linear. Each piece of it, this piece is linear, that piece is linear, but it is not a linear function. Just to give you an idea of what we're talking about when we talk about linear versus nonlinear. So these three, if I light them up, whoops, there we go. These three are all nonlinear, okay? Now, let me just show you another little trick. Let me go back up here. Let me get rid of a few of these. And let's just put these two up. And I'm going to go up here to the wheel. If I hit the wheel and I go in here and I touch this, I can change whether it's a dashed line, a solid line, a very busy little line. I can change its color if I would like. There's a lot of little things you can do. I can create a table real quick if I need a table of terms. If I wanted to know what the points were at, let's just say I wanted 99. They asked me what is this value at 99? I can just type in 99 and it will spit out the answer for me. Just kind of a background reminder kind of thing. So let's review for a minute. There are three different types of linear equations. Y equals mx plus b, where b is your y-intercept, and m is your slope. So if I were to draw a graph, find where the y-intercept was. This is your y-axis, this is your x-axis. So let's just say my equation is y equals 2/3 x plus 4. Okay, just made it up. So we go 1, 2, 3, 4. Here's 4. So I'm going to put a dot at 4. Here's 4. I'm going to put a dot there. Okay, that's where that came from. From that point, I'm going to go up 2, 1, 2, 2, up 2, okay, and then I'm going to go over 3. So 1, 2, 3. So that's over 3. There's my next dot. Once I have 2 dots, I can connect them. That gives me my linear equation. It's a straight line. Y equals mx plus b will always be a straight line. Now, the other equations, just so you remember them, ax plus by equals c. That is standard form. And then there's also y minus y1 equals mx minus x1, where these two, x1 and y1, are your ordered pairs. Those are your points. And m is your slope. The other piece of the equation that I want you to remember is the slope equation. So if I am looking for slope, of course we call that m, and that is your delta y over delta x, which is x2 minus y2 minus y1 over x2 minus x1. If we have parallel lines, our slopes are equal. Perpendicular, and we usually make a symbol like that for parallel, and make a symbol like that for perpendicular. And perpendicular lines are negative reciprocals of each other. So one's going to be n, and one's going to be a negative 1 over m. Well, what does that mean? I'll give you an example because it tends to make a lot more sense to me. If I have 2/3 for my first line, then my new line, because this one was positive, this one is now negative, and because this was 2 over 3, it is 3 over 2. Again, like I said, negative reciprocals of each other. Parallels up here. Maybe that should help. Now, let's look at Desmo and look at some equations. Okay, so I've typed several equations into here so that you can recognize that they are all linear equations. Why are they all linear? Look at the y's. What are they raised to? I don't see anything. Well, the reason you don't see anything is because math teachers won't write a 1 here. So these all have a 1 here and here and here, but we won't write them. So they're raised to the first power. Then I look at the x's. X is raised to the first power, X is raised to the first power, X is raised to the first power. We won't write it. You have to know it. If the X and the Y are to the first power, then this should be linear. So let's look at this and see what this looks like. Okay, so the first one in green is right here. And I can see that it is a line. It is linear. What does this 2 in front of the X mean? That's the slope. Well, when I showed you the equation y equals mx plus b, there was an add-on to the end of it, a plus b. I don't see anything. What do I see here for the plus b? I see plus nothing, right? Well, did I change that equation? No. Do I need to write that 0? No, it's a waste of my time. This does go through 0, 0. The y-intercept, the y-axis, this goes through the 0 point. Let's turn that off and look at the next one. Similar equation. It's got a 2 in front of the x. That means its slope is 2. But what's this 4 mean? The 4 means the y-intercept. Let's just look at that quickly, and we can see that it goes through the 4 as my y-intercept. Now, let's look at this one. Again, the slope is the same. The x value, the value in front of the x, the coefficient to the x is 2. So that means that the slope is 2. It means up 2 over 1. Remember, I could retype this if I wanted to, making no change at all by hitting divide by 1. Did I do anything? Absolutely not. The rise is 2, the run is 1, right? Rise over run, slope equals rise over run. So let's just turn that one on. What do we notice about this one? Seems to be going up at the same rate, but where does it start? At -3. What did this say here? -3. That's all we're saying is the y-intercept is at -3. Now let's look at all 3 of these all at the same time. Red, blue, and green. What do you notice about all 3 of them? Well, they're all going up at the same rate. The rise over the run is the same. The slope is the same because if I look here, this is 2, this is 2, and that is 2. Remember, I kind of cheated and put the 1 in there. Math teachers won't do that. All these are the same. The slopes are all the same. If the slopes are the same, they're all parallel. Okay, here's my first example. I want you to look at it very quickly. I've written them both out already for you. And if I look at this, I wrote f of x instead of y. They are interchangeable, right? That's still y equals 1.02x plus 100. Well, look at the x. It's raised to the first power. Is this a line? Absolutely. There's my line. Now I know I have a line. Let's look at this one. Is this linear? No. Look at this very carefully. This 1.02 is raised to the x. The x is an exponent, so therefore this is not going to be linear. Do you see that? This is not a linear function. It is a line. Now the question they asked when they were asking me this question was, when will these 2 lines intersect? Where is it that they intersect? Well, they actually intersect in 2 places. For this particular example, they were asking what was the smallest integer I could pick that was positive. But I'm going to talk about both spots. I have a negative here, and that is negative, let's call it 90. It's almost 90. It's a negative 89.75. But that's a negative integer. It's not what they asked me for. And then they asked me for the positive integer. Well, the point is 58.696. Let's call that 59. So I would say approximately 59 would be my positive integer. Here, once again, I've already put the things in. I should have turned them off. I'm sorry. Here we have raised to an x. So therefore, this is nonlinear. This is to the first. So this is linear. Let's look at this. This is linear. Yep. This is nonlinear. Yep. It's a curve. And where is the point where they intersect? In the positive range would be 78.32. If they asked me for the negative, it would be 4.669. If they asked me for an integer, I would have to say it was approximately negative 5. This time they created a table and asked me when they were the same. Now I can look at this table and clearly see right here that the 2 values are the same. Or I can look right here on my graph and see that both of them are the same. These are really quick to make.